cost is also a factor, I will choose two-state pair, right? Two-state pairs are available in different categories, that. So depending on your budget, right, you may one kind of a two-state pair, whether you are category 3 or category 5, right? And using those two-state pair, you can transfer data for a smaller or to a considerable distance, I can say, like in a building or in a nearby place, right? So, which is like not a very large distance, but so that you can achieve a good data rate. So as you have seen that the two-state pair is widely used in ring topology. Also, you can use, because ring is a point-to-point link. Point-to-point links are there between the two stations. So you can use a two-state pair one, and bus also you can use, star also you can use, right? So similarly, coaxial cable, which can provide you much higher data rates as compared to a two-state pair, and you may transfer data for a longer distance, right? So you can go for a coaxial cable. Coaxial cable also we have discussed. There are two types of coaxial cable: baseband coaxial, broadband coaxial, and we have also seen the difference of the baseband versus broadband, right? And you can see that the baseband could only be used for a smaller distance, while broadband can be used for a tens of kilometers. And an abridged form of both baseband and broadband is called as a carrier band, right? So the coaxial cable, and I have shown you the thing that so you can use coaxial cable, but coaxial cable, using coaxial cable is a bit tough when you have to install the on a physical interface, right? So that is tough, installing stations on the coaxial cable, and removal and new installation. So that is quite complex thing, right? Otherwise you can use coaxial cable, but they are at a higher price. You have to pay more money. So if you have used that Ethernet cable, that also is a baseband coaxial cable, right? And in your cable TV also you use it, that is also a baseband coaxial cable, right? So this is again baseband and broadband transmission. As I told you in the previous class, that a baseband LAN uses digital signaling. So binary data to be transmitted are inserted on the cable in the form of voltage pulses. So we use Manchester differential Manchester encoding. Data travels in the, and at the end this data is absorbed by the terminating resistances. But this is a baseband. As you know that the broadband is a unidirectional. Broadband is unidirectional. So when you are transmitting data, so how you can get a feel of a bidirectional data transfer, since broadband is unidirectional? So there are two possibilities to use a broadband. One is called as a dual cable broadband. So there will be one cable on which a transmission will occur, and the other cable, the reception will be there. So like that, and there will be a passive head end through which the cables will run, right? And there can be another option when you don't want to go for a higher cable requirement, because this arrangement is simple and less costly as compared to the other one, that is called as a split configuration, split configuration, split broadband, where there will be only a single head end here, right? This is nothing but a frequency converter or a demodulator. So that the signal will be transmitted by the station at a frequency f1, and it will just change the frequency to another frequency f2, on which the data will be received by all the other stations. So this can be so this is very costly, because this kind of arrangement is a costly one. But in case where you have to cover a larger distance, or so then that this arrangement may be cheaper, because you have to run two parallel cables in case of a dual cable broadband, which will be costly, right? So dual cable is cheaper for a smaller system, because the fixed cost of this head end is noticeable, and single cable is cheaper for larger system where incremental cost dominates, right? So there, so that is the difference in this. Now I have a very general question, right? That generally most baseband coaxial cable, this is an important thing, right? That the most of the baseband coaxial cable uses 50 ohm cable rather than standard cable TB of 75 ohm. Can you say why? Where this 75 ohm says the impedance of the cable. What is basically an impedance? Impedance is nothing but a measure of how much voltage must be applied to the cable to achieve a particular signal strength, right? Can you say? Anyone? Because for digital signals, the 50 ohm cable suffers less intense reflection from the insertion capacitances of the taps, because the stations are connected through taps, right? The stations are connected through taps, as you have seen in a bus topology. That is basically a hardware interface that is provided. Okay, so basically, so that hardware interfacing is known as a tap, right? So through that tap, the tap offers a so there is an insertion capacitance of those taps that provides better immunity against low frequency EMI. Okay, so that is why mostly the base for baseband coaxial cable, a 50 ohm cable is used rather than a 75 standard 75 ohm coaxial cable, right? So there are many trade-offs. So we talked about bus topology, right? So bus topology or tree topology, tree is just a generalization of a bus topology. So basically there are two problems that, as I told you, that in a bus or tree topology, that a transmission via particular station will be received by all other stations, right? This is one thing. Then the second issue, so to deal with that, we require some MAC protocol, right? There is a MAC protocol called token bus, right? So we require a MAC protocol to regulate the access of the shared medium, okay, so that all the stations will get a fair chance to for transmission of data. But at the same time, there is another issue that is called as a signal balancing that puts a limitation on the length of the cable bus length. Can you say what is that? I told you about signal balancing. It's an important topic. That what is signal balancing, right? So if the exams are going to be in the like even in the this also quiz also, this type of questions can be asked, right? What is signal balancing? Because you know that the when the two stations exchange data over a link, the signal strength of the transmitter must be adjusted so that it remains in certain limits. Because as I told you earlier, that for a point-to-point connection, it doesn't matter. Because like for a particular link, suppose the two stations are exchanging the data on a point-to-point link, the signal strength, I told you about the signal to noise ratio, that the signal strength should be sufficiently high so that once it reaches at the destination, the receiver should be able to recognize the data, right? The signal strength should not be too weak so that the noise will dominate the signal power, right? And there will be only noise. So the station, the receiving end will not be able to differentiate, right? So the signal power should be so adjusted that once it reaches at the destination, it should be recognized by the receiver. But the signal strength should not be too high, so that that can introduce the non-linearities mm, in the receiver circuitry. Okay, uh, so just to deal with this issue, because if we are talking only about a point-to-point link, this seems very normal thing that we can easily adjust the signal strength between these two stations, right, on this particular link. But when we are talking about a network, right, where there will be n number of links, n number of stations, so there will be a possibility of n into n minus 1 particular links adjusting among the stations. So to adjust the signal power on each link will be a difficult option. So what is the solution? The solution is that we should divide the LAN, right? We should divide the entire LAN into different segments, right? And different segments needs to be connected through a repeater. This repeater is nothing but a transparent repeater. So whatever transmission is coming from this particular segment one, right? This repeater will take it and will regenerate on segment 2, right? And later you can replace these repeaters with some kind of a switch mechanism or something where so they can provide you the guided transmission. So this type of breaking of the LAN into smaller segments, that just to restrict the length of the because it is required to avoid the issue of signal balancing, right? Because in some systems we also use RF frequency, RF signal. So that basically this problem compounded when there will be a possibility of RF signal interference with across frequencies. So then this problem will get multiplied. So the common solution is to divide the medium into smaller segments within which pairwise balancing is possible. Okay, so we can use an amplifiers or repeaters between this to adjust this issue, right? Now I will be going to the ring topology, right? So bus and tree topology I have already told. So there the issues also I have discussed, right? Another thing I asked you that why the tree topology, you will find that the tree topology is not used here for the baseband, because the tree topology is having a nature of this unidirectional data transfer, right? The tree topology so it can easily be employed with your broadband coaxial cable, because broadband is also unidirectional, right? Broadband is also unidirectional. So that is why this is not used. The tree is basically used with broadband because of its unidirectional nature of data transfer. Now I am coming to the ring topology. Please then star topology already we have discussed. So then we will enter into the MAC protocols. So there are some issues which are related with the ring. So as you know that I told you that the ring is So you can see that I told you earlier that I told you about the basic working of a ring topology, that the data travels in a unidirectional fashion. Either the data can travel in a clockwise direction or in the anti-clockwise direction. So basically, a ring consists of a number of repeaters, right? These are repeaters which are associated with each station, right? Uh, So data is transferred sequentially bit by bit around the ring from one repeater to the next. So each repeater regenerates and transmits each bit, right? So I told you that earlier that when a station A wants to send something to station C, so it transmits that on the link, and then while passing through this repeater which is associated with station V copies the data, copies the entire frame, and in that frame it checks whether it is for station B, then it passed the information to station B, and then station B checks whether it is for this station or not, and then if it is not, it regenerates the entire pattern without copying the frame. It regenerates the entire pattern on the this side of the link, right? So like that, this data moves in the ring, and finally the source station has to remove that frame from the LAN, because it serves two purposes. Because returning it back to the source station means that will also serve as an acknowledgement to the source station that whether the frame has been copied successfully or not. Then second thing is that if it is not, it permits some kind of a multicast addressing also, because one frame is sent one frame from one frame can be sent simultaneously to multiple stations also. So this is the advantage of the source station to remove the things, right? Can anyone say what do you mean by the bit length or bit latency of the ring network? Huh? Length or bit latency of the ring? Can you say what is bit length of the network? Ankush? Ankush? तुम नहीं बोलोगे तो कैसे चलेगा? कार्तिक?
Yes, sir.
What is bit length of the ring? As I told you that the data travels in the form of bits on the ring LAN. So what is the bit length of the ring? Bit length of the ring means the total number of bits can be that can be present on the ring network is called as the bit length of the ring, the total number of bits, right? So that is fixed. That if I am saying there can be 256 bits on this LAN, so that means maximum 256 bits means your frame size will be adjusted accordingly, and then this repeater also introduces a 1 bit delay. So like that, this bit length refers to the total number of bits present on the ring length, right? So for a ring to operate as a communication network, three functions are performed by the repeaters, right? Uh, First is data insertion, data reception, and the third is data removal. So what is that? So as you know that just now I explained you that when the data is transmitted in the form of frames, which has the destination address, I told you that otherwise every station will copy the frame. To avoid that issue, what we do, we in a frame we provide some sort of control information. In the control information there is a mention of source address, destination address. So just the repeater which is associated with the station, okay, as an attachment point, right? As the frame circulates and past the repeater, the address field is copied to the attached station. Okay, because when the frame is coming, once this frame is coming, right? So the first one will be the control information, the source and destination addresses. So first it will copy this and pass it to this station, right? If the station recognizes the address, the remainder of the frame is copied. Otherwise, it will simply pass the frame, regenerate the frame on this line, right? So repeaters perform the data insertion and reception functions unlike the taps on the bus, because taps serves as an attachment point on a bus or a tree. And the data removal, I told you that the data removal is done by the source station itself, because it serves the purpose of an automatic acknowledgement. Okay, and it also allows multiple multicast addressing, right? So if I have to say that how the repeater works in three different states, right? A repeater works in three different states. Okay. Three different states. So the first one is called as a listen state. So the data is coming to the repeater and it simply passes to the station. As I told you, when the data frame is coming, it copies the address part and sends to the station. Okay, and then if the address is recognized, then only it copies the remainder of the frame. Otherwise, it regenerates the pattern on the ring. So in this process, it introduces a 1-bit delay. Every time it copies the frame, so 1-bit delay is introduced every time once the pattern is copied and regenerated by the repeater. The other state, which is called as a transmit state. This is called as a transmit state. So in this state, the data comes to station. And from station, so you can see the clear difference that it is not introducing any delay in this process, because the transmit state means, right, whatever is coming from the station, it will regenerate, or whatever is coming, it will copy it to the station, like whether it is to be removed or this thing. And the third state is called as a bypass state, because you know that the repeater introduces a 1-bit delay. So suppose if some of the stations which do not have any data to send, or they are not even participating in the network, then keeping a repeater, right, always will introduce a 1-bit delay. So in that case, the repeater can act as a bypass state, where it will simply bypass, right? It will not take part into it. Otherwise, if it is going through the repeater, it will again introduce a 1-bit delay, right? So this is called as a bypass state. So I am just restating that in the listen state, each bit that is received is transmitted with a small delay, right? Because this small delay is required to allow the repeater to perform necessary functions, because this delay is of the order of 1-bit time. Okay, basically what the repeater is doing, it simply passes the bit stream, okay, and find out the address of the attached device. Okay, sometimes when we will use token ring or something, it has to see the token. Okay, and so it basically scans the uh, bit pattern, right? Copy each incoming bit and send it to the attached station. It copies each incoming bit and send it to the attached station, while continue to retransmit each bit. Okay, sends the station and then continue to retransmit each bit. So this will be done for each bit of each frame addressed to this station. This will be done for each bit of each frame addressed to this station, right? So this is the job of a repeater in the listen state. When a repeater station has a data to send, and when the repeater has permission to send, it works in a transmit state. So the bits can be whatever it is. So if a station has data, it will be sending. Okay, so the bits could be from the same frame that the repeater is still sending, or कैन यू से ऐसा हो सकता है कि मान लो रिपीटर एक ट्रांसमिट कर रहा है और उसको अपना ही रिसेप्शन वापस भी मिल रहा है. इज इट पॉसिबल? एंड इफ इट इज पॉसिबल, व्हेन विल इट बी पॉसिबल? एनीवन? इट्स एन इंपॉर्टेंट थिंग. You are not following, please ask.
Sir, when the data is corrupted and no other station receives it.
No. I'm not talking about the corrupted है या नहीं है. Okay. I am saying that there is a possibility when this station B is transmitting, right? So this repeater is sending the signal because the data frame is large, right? So it is transmitting. So repeater is generating the bit on this link, and at the same time this will come back, and the leading edge of the frame will reach back to this repeater, and it has to start receiving also. So is it possible? Yes, it is possible. I asked you in the beginning that what do you understand by the term bit length of the ring? Because it will depend on the bit length of the ring. If the frame length, the length of the frame which a station is transmitting is larger than the bit length of the ring. Bit length क्या है? कितनी bits रह सकती हैं? मान लो ये 500 bits का है. Okay, frame is of 500 bits and bit length is 256 bits. तो क्या होगा? जब ये ट्रांसमिट कर ही रहा है, it has not finished its transmission, okay, it is regenerating it on this line, it will start receiving it from this end, is it not? Because once the leading edge of the frame reaches back to the transmitting station, it serves as an acknowledgement, right? Because I told you that once the entire frame reaches back to the source station, it serves as an acknowledgement to the source station, whether the frame is copied or not. Copy हुआ नहीं हुआ, कोई error थी frame में, this is all we will discuss later. But for now, so there can be two possibilities. That if the frame length is higher than the bit length, right, then the repeater will start receiving its own transmission. And the second possibility is that if the frame length is smaller than the bit length, this repeater, this will regenerate the entire pattern. Then after some time, it will receive its the first leading bit of the frame, right? So it depends on the bit length and the frame length, right? This is a very important thing then when we will discuss about the MAC protocols, because this is a very important thing. जैसे मान लो आपने आप कोई बॉल फेंक रहे हो, राइट, इन अ रूम, स्मॉल रूम, you have thrown a ball, okay, then the ball comes back to you. But if you are sending it in a larger room, it will take time to come back to you, right? मान लो आपने कहीं दूर दीवार पर बॉल मारा, then it will take some time to come. And if you are hitting the ball at the nearest wall, then it will immediately come back to you, right? So similarly, so it depends on the frame length, and there are possibilities. There is another possibility that I told you, that the ring topology, when used with optical fiber, we say it as a fiber distributed data interface, FDDI, which is a very high speed LAN on so that basically there is a possibility that in such scenarios, when you are talking about a very high speed LAN, it is not like that there will be always a single frame will be traversing on the ring. There may be multiple frames may be there on the ring at the same time, right? To improve the efficiency of the ring, right? Multiple frames can traverse in the ring. So this is it depends on this bit length and the frame length, right? So both these two listen and transmit states are sufficient for proper ring operation. The third state, that the bypass state, is also useful, because once this bypass relay is activated, so as I told you that the repeater introduces a 1-bit delay. So once this once the repeater is in the bypass state, it simply bypasses it, right? So it will basically improve the performance by eliminating the repeated delay. Like, because as I told you that some of the repeaters may not be active on the network. So in that case, it will simply bypass it. So it will simply bypass it. So it simply eliminates the possibility of the repeated delay. Can you say now? Can you say what are the as compared to bus tree topology, right? Which one is better as compared to bus and tree ring? Can you say discuss the advantages of ring topology? Bolo. As compared to bus and tree, what are the advantages of the ring? The most important advantage is that it uses a point-to-point link. And there are repeaters. So you can, because at each node the signal is regenerated. So the greater distance can be covered, right? So ring can be used to cover a larger distance as compared to bus and tree, which can cover only a smaller distance, right? And moreover, data integrity is also assured because your data is not lost, right? And you can also go for optical fiber links, which can offer you no EMI EMC, right? No EMI, and can provide you higher bandwidth. Another advantage of ring is that the fault isolation is easier as compared to bus and tree, because here one particular station failure, right? And like fault detection and fault isolation and recovery are simpler, because suppose if the two stations are given the same address, in case of a ring it can easily be identified, but if in a bus or a tree topology, if the two stations are accidentally assigned the same address, there is no easy solution to find out that whether where is the duplicate address. So and ring topology offers you that you can transfer data on a longer distance at a higher data rate, and your data integrity is also maintained, right? But the only issue is so it offers a greater throughput as compared to bus and tree topology and even star topology also. But the only issue that lies with there are many issues with lies with the uh, ring topology. One of the basic issue is that the cable vulnerability, right? So if the cable is cut at some point, right, so the entire network will get disabled until the problem is isolated and the new cable is installed. Then repeater failure. So if the repeater failure, so that also will disable the entire thing. So there can be possible potential ring problems. One I told that the cable vulnerability. So if cable is cut from somewhere, you need to isolate the fault and then install it. So as I told you that the ring topology can cover a larger geographical area, right? So there isolating a fault and then is a bit difficult, right? Because it is vulnerable at every point. Similarly, repeater failure will also disrupt the entire network. Okay. Then the third is preambulation. Preambulation means this problem is called as a pocket full of keys. So this issue is called as a pocket full of keys. Just like you have a bunch of keys, right? You have to open some room. You have to open the lock of some room, and you try all the possible keys, and then sometimes it happens that at the end only you get the correct key, right? When you have tested all the keys. Similarly here also, like if a repeater fails, right, which particular repeater is failed, to detect that, right, you need to check, because it requires locating the failure, requires preambulation of the ring. So you have to have access to all the rooms containing repeaters and cables and then checking it, right? So this issue is called as a pocket full of keys issue. Then a very critical thing that is called as a size limitation, that how many stations you can have it on a ring. Can anyone say? And if how does this size limitation um, come into picture? Anyone? Anyone? Size limitation. Size limitation means the number of stations that you can have on a ring LAN, right? How many maximum stations you can have it on a ring LAN? Any idea? Just now I told you what is the function of a repeater. Anyone? Atul Kumar? That the repeater introduces a 1-bit delay, right? Repeater introduces a 1-bit delay. So if you have n number of stations, right? So that means you have n number of repeaters installed on the network, and when the frame is moving to each one of the station, right, it is introducing a 1-bit delay in that, right? So this and sometimes what happens, this delay, okay, this variation in the bit length, because this result in the variation of the bit length. So this issue uh, leads to a problem called timing jitter. Can you say what is jitter? What do you understand by the term jitter? This issue is to deal with, like, because when you have large number of stations, what will happen? The repeaters will introduce delay, and because of that delay, because the bit length of the ring is fixed, okay, some of the bits needs to be dropped, some of the bits needs to be added, right? So this timing jitter issue is a critical one, because this timing jitter deals with the uh, can you say the term called delay distortion? You have studied delay distortion. Can you say what is delay distortion? Anyone? Delay distortion. Kumar Sangam, can you say what is delay distortion? शुभम, डिले डिस्टॉर्शन, ये सब तो पढ़ के आए हो डेटा कम्युनिकेशन में. व्हाट इज डिले डिस्टॉर्शन?
So data that is transmitted comes at different times, so the received data is distorted.
Right. So because if you say delay distortion is basically caused because the velocity of propagation of a signal through a guided medium varies with frequency, right? So the component of the signal component of one pulse will spill over into the other pulse, right? Other pulse position. So this leads to a term called intersymbol interference. If you आपको याद होगा ISI, right? That I shape comes into that. So, and this is also similar to that only. This is called as a Timing jitter is nothing but a clock deviation. It's a very important term. This is a very important thing. It's called as a clock deviation. So the practical limit on the number of repeaters on a ring, because this limit is basically related with the reliability and maintenance problem of the ring, because as you increase the number of stations, it will be once again difficult to find out which particular repeater is failed or where exactly the cable is cut, right? So first thing, then the other thing is the timing jitter, because the large amount of delay will be introduced by the repeaters. So so we can limit the number of repeaters in order to save that delay. So we will be discussing this timing jitter in detail, right? Generally हम लोग क्वेश्चन पूछते थे what is the which factor limits the number of repeaters on a ring topology, right? And what is the possible solution to increase the number of stations, right? So then installation headaches are also there in case of a ring installation. Because once you are installing a new repeater, right? Suppose you are installing a new repeater, this is already a existing station, right? And you want to install a new repeater here, right? This is a new repeater. So what you have to do, you have to find out that this new repeater is located at an equal distance from this repeater and this repeater, from its adjacent repeaters, right? Because then otherwise there will be issue with the signal balancing and other things. So you need to find out, once you are installing a new station on a ring topology, these two repeaters, this new repeater should be topologically adjacent repeater between these. Topology means it should be at the same distance from these two repeaters, right? So so you need to identify whether they are exactly adjacent to each other, and cable must run from the new repeater to both the repeaters, right? And the length of the cable should be same, right? So because otherwise what will happen, the geometry of the ring will be irregular, so that will result in perambulation problem, right? So now the last thing is, that is an important thing, that is called as a timing jitter. So this we will be discussing it in the next class, right?